Okay, so we are going to go ahead and move forward with section 1.3, and this is going to be all about defining the trig functions. Okay, now there's a couple of things that I want to kind of throw in as refreshers that will help us with this section. And the first one is rationalizing the denominator. I know it's been a hot second since we had to do that, so over here to the side I'm just going to kind of refresh you on how to do that. Okay, review of rationalizing the denominator. Because whenever you work through your problems on this section, some of them will come up with answers that have a radical in the denominator, and we never want to leave a radical in the denominator. We always want to make sure that we have a nice pretty number in the denominator, and it's okay to have a radical in the numerator, but the denominator, that's just frowned upon. So if you end up, let's say you end up with something like 3 over the square root of 7, something like that. Okay, in MyMathLab, if you enter it like that, it'll say that it's not fully simplified because there's a radical in the denominator. So what we want to do is we want to multiply by a form of 1 that will cause this radical to simplify so that we don't have a radical. In other words, it's a square root. I need a perfect square under it. So instead of a 7, it would be really nice if that was a 49, right? Because if I had the square root of 49, then that would just equal 7. So that's what I'm going to do, is I'm just going to multiply by whatever that radical is that I'm trying to get rid of. I'm going to multiply it as a form of 1. Because if I multiply by any number over itself, that's just multiplying by 1, and that doesn't change the overall value. Okay, so when I get that, that gives me 3 times the square root of 7 on top, and on bottom, when I do the square root of 7 times the square root of 7, that gives me the square root of 49, which then just simplifies to a 7. So this would just be 3 square root of 7 over 7. Okay. And I know that y'all had to do some simplifying like this in the college algebra class. Did my video freeze? There it goes. Okay, I know y'all had to do some simplifying like this in my college algebra class, but since it's been a hot second, we've all slept since then, I just wanted to refresh it since I know some of your answers will come out with these radical denominators. Okay, so let's look at one more. Let's say your answer was like -2 over the square root of 3, something like that. Okay, again, you just want to make that radical a perfect square so that it basically simplifies away, right? So instead of a square root of 3, the closest perfect square that we can get is 9. So we can just multiply by square root of 3 over square root of 3 to make whatever radical is on the denominator a perfect square, right? So this gives us -2 square roots of 3 over square root of 3 times square root of 3 is the square root of 9, right? Which then just becomes 3. Okay. So again, we're not to the point where we're having to do this yet, but I just wanted to throw in a little bitty review so that when it comes up and I say, okay, now we need to rationalize our denominator, we can go back and see this as just kind of like a little refresher. Okay. All right. So here is how we are going to, define our trig functions. Okay. They're saying, let's let xy be a point on the terminal side of an angle. So here's our terminal side, right? Because the angle starts always at the positive x-axis, and then it terminates at this ray, right? Or I guess a line segment, because they didn't draw it. Keep going. So we have this point xy of this angle theta. Okay. So a few things to make sure that we note. Theta is in standard position. That means we're going from our positive x-axis up to our terminal side. Okay. Notice the point that we choose here, xy, cannot be 0, 0. Because notice this terminal side, this distance here, r, shows the length from 0, 0 out to our point. So it wouldn't do us any good to use the point 0, 0 because then we have no distance here, right? We have no triangle to draw. So, and that is a good thing to note, is that R is always positive, okay? Because it's the distance, ooh, I think my pen's gonna die, from our angle theta to the point xy. Oh, yep, that marker has passed on to the next life. All right, let me go over some of this and hopefully you can see it. I'm using a different microphone to record, so I'm trying not to talk in my normal loud voice because it's right here on my document camera, and I'm hoping that once this records, I'm not screaming at you. All right, so this is just our xy point, right? So we have our distance y, we have our distance x, and then we also have this positive distance that will always be positive, right? Because it's a distance from our angle theta out to the xy point. Okay, so if we want to figure out what this r distance is, if it's not given to us, we can easily figure that out just by using the Pythagorean theorem, right? Because we know that, you know, one side of a right triangle squared plus the other leg of the right triangle squared equals the hypotenuse squared, right? So the little formula they have down here to show you what r is equal to, this is just from the Pythagorean theorem, okay? And that's just a shortcut way to help us solve for r if r is not given, okay? All right, so now that we have it all defined, we have this triangle with our angle theta in standard position. How we're gonna define our 6 trig functions is as follows. Sine theta, and you always have to write the angle, okay? You can't just say sine is whatever, because sine without an angle is a sin, right? So we don't want to just write sin. We want to make sure this is representing the sine value of an angle theta, okay? So make sure you write your angle in there. So the sine value we get by doing our y value, or this y distance, divided by our r distance, which is that hypotenuse distance, okay? Our cosine value we get by doing our x distance over our r distance, and then our tangent theta function value is our y over our x. Okay, now before I go on to talk about these, I just want to point out something. Anytime we see our y over our x, that should maybe just remotely remind us of slope, right? If I wanted to find the slope of this line, right, if this terminal side line was just a regular linear line going from 0, 0 out to whatever point, and I wanted to find the equation that represented that, I would need to know its rise over its run, right? And so the way I would find that is this change in y over the change in x. So I'm just going to note over here when we look at our tangent value that this also represents the slope of the terminal side line, and that will come in handy later. Oh my goodness, my pens are just dying. Let's see if I have a different color. Epic fail on the pens tonight, right? All right. Okay, so that was our sine, cosine, and tangent. And then these side, the way that we get these trig function values is basically just by doing the reciprocal. Notice the only difference between sine theta and cosecant is that we are doing the reciprocal of the value. So instead of doing y over r, we're doing r over y, right? And for cosine, we do x over r. For secant, we do r over x, right? And then we have tangent and cotangent that are also reciprocals. So I'm just going to put a note here. Notice these are reciprocals. meh, meh. Okay, so that will help us memorize these moving forward. Okay, so I just want to show you an example of if we're given an angle theta and we know that it starts at the origin and it goes out to some point. I want to make sure that we know how to define all these trig function values. Okay, so that's what we're going to do at the bottom of this page, is go ahead and draw a triangle to represent this angle theta. And it says it has a terminal side passing through the point 12, 5. Find the 6 trig function values for theta. Okay, now this ordered pair they gave me, this is just an XY ordered pair. So if I want to draw this, excuse me, that means on the x-axis, right? On the x-axis I'm going out to 12, and on the y-axis I'm going up to 5, right? It doesn't have to be perfect, I'm just making a little sketch. So this point 12, 5 is somewhere like that, okay? So we know the terminal side, which always starts at 0, 0, right, is going to pass through that point. So this is what our triangle looks like. If I just drop down from that ordered pair, here's my little triangle, right, which now I can go ahead and label. So I need to know, in order to find all my trig function values, I need to know what x is, I need to know what y is, and I need to know what r is. So x and y I can get off of this point, right? I know that I went from 0 out to 12, so I know that my x value is 12, and I'm going to go ahead and just write them down here. X is 12. I know that my y value is this distance, right, which is 5. So y is equal to 5, and now I just need to figure out what my r distance is. So remember, if we look up here at the top, or really the middle of the page, top of my screen, but middle of your page, we can find r using the Pythagorean theorem. So all we have to do is square x, square y, add them together, and take the square root. So that's what I'm going to do down here. R is the same thing as the square root of x squared, so 12 squared, plus y squared, which is going to be 5 squared. Okay? And then I simplify. So I get the square root of 144 plus 25. If I add 144 and 25, that gives me the square root of 169, which is 13. So that was nice. It came out to a nice, pretty r value. Okay, so I'm going to erase my question mark here because now I know what r equals. I know that r equals 13. Okay, so now that I have determined what my x value is, what my y value is, and what my r value is, now I can go ahead and write out all of my trig function values. Now, make sure when you write these out that you're writing your computation or your formula. In other words, I want to see sine theta equals, and then your answer, right, or whatever you needed to do. I'm going to go ahead and write out the little formula just so that we get used to it. Sine is y over r, and in this case, y over r would be 5 over 13. Okay, cosine theta is equal to x over r. Whoops, breaking my pen, running out of ink. Okay, and x over r for this angle is going to be 12 over 13. Okay, so when I say show your computations, I know that a lot of you just like circle your answers and stuff on worksheets and exams, but I want to be able to see your sine theta, your cosine theta, because if all you have are all these little fractions, I don't know which one goes with which means that I don't know if you did it correctly or not, right? All right, and then we have tangent theta. Tangent is y over x. Right? So our y value is 5, our x value is 12, which also gives us the slope, right? Remember our little side note here? So that actually gives us the slope of this line, because notice we're rising 5 and we're running 12, right? And then to find our other trig functions, now all we have to do is calculate the reciprocal. So in order to find cosecant theta, I'm going to do r over y, which gives me 13 over 5 I do realize you can just flip the fraction, but I'm going to go ahead and write this because if you're not familiar with the trig function definitions, writing it every time you do it will help you remember it. Okay, secant theta is going to be r over x, which gives me 13 over 12, right? And then our last one, cotangent theta, is x over y, which gives me 12 over 5. And you don't have to write that as a decimal or an improper number or anything like that. We want to just go ahead and leave it, or sorry, it is an improper. We don't want to write it as a mixed number. Okay, so just leave it like it is. Okay, all right. So now that we've seen a nice pretty example of being able to draw the triangle, find our r value, and then denote all of our trig function values, I want to show you another one on the next page where two things happen. One, I want to kind of look into this idea of using a specific xy point here. You know, what if we were to use this point, or what if we were to use this point? Like, does it matter which point on that ray you use? Okay, so we're going to kind of explore that. And then also I'm going to show you what it looks like when our r value doesn't come out nice. So like this one came out to 13. Oh, that was pretty, and it made all these pretty fractions. But if we get something that has a radical, you know, then we're going to have to rationalize the denominator for each of our little trig function values. Okay? All right. So let's look at page 2 and see what it says. It says, draw a ray with the endpoint 0, 0 that goes through the point 1, 2. Okay, so this is my x-axis, this is my y-axis, and it's saying we're drawing a ray that goes from 0, 0 to the point 1, 2. Remember, this is just an xy pair. So we're going to go to where x is 1, which is here, right? And where y is 2, which is here. So that gives us this point. Okay. So right now our array looks something like that. So if I drop this down and create a little bitty triangle right here, I should be able to find all of the trig function values off of that little triangle. Okay, so what I know about this triangle is I know what my x value is, right? My x value should be just the value in the ordered pair they gave you, which is 1, right? This little length here is a 1. I know that my y value is the value of my ordered pair, right? Or this distance, which is 2. And then I can calculate my r, right, using the Pythagorean theorem. So if I square this side and I square this side and I add those together and take the square root, I can figure out r. So I'm going to go ahead and say r is the square root of my x value squared, which is 1 squared, plus my y value squared, which is 2 squared. Okay, and then I'm just going to simplify this to see what it comes out to. So this means r is equal to the square root of 1 plus 4. So that means that r is the square root of 5. My cat is having a sneezing attack over there, if you're wondering what that noise is. Bless you. Okay, so now that we know what x, y, and r values are, we should be able to go ahead and fill in these trig functions. Now I'm not doing all 6 right now, I'm just going to do sine, cosine, and tangent. So if I want to find the sine value, I need to know what y over r is. So my y value is 2. My r value is the square root of 5. And notice that's going to give me an answer that has a radical in the denominator, right? So before I could enter this on my math lab, I would need to go ahead and rationalize the denominator. So remember, from the beginning of this section, to rationalize this denominator, I would go ahead and just multiply by the square root of 5 over the square root of 5, right? That way on top, and I don't have room to write it, so I'm going to write it down here. So that way on top, I would have 2 square root of 5, and on bottom, when I do square root of 5 times square root of 5, that would give me square root of 25, which then just becomes 5. So this would be my sine value. Okay. And I want to do the same thing for cosine. Okay. So for cosine theta, we're looking for x over r. Our x value is 1. Our r value is square root of 5. And again, we need to rationalize the denominator, right? So I'm going to go ahead and pause just for a second so that y'all can work on these. So I want you to go ahead and rationalize the denominator for the cosine, and then I want you to figure out what the tangent function value is. Okay, so go ahead and pause the video while you do that, and then when you're ready, unpause it and we'll go over it. All right, so let's see how you did. So on the cosine, we had 1 over the square root of 5. In order to rationalize that denominator, we do square root of 5 over square root of 5. Now when I multiply on top, I do get 1 square root of 5. But 1 times anything is just, you know, that value. So go ahead and don't write the 1 on top. If you're just multiplying by 1, all we need to put is the square root of 5. And then on bottom, square root of 5 times square root of 5 is square root of 25, which then becomes just 5. Okay, and then our tangent, y over x, gave us 2 over 1, which is then just 2. Okay, all right, so now what we want to look at is, it says, note that the terminal side of theta also goes through 2, 4. So remember how we talked about the tangent value also being our slope, right? I'm just going to put a note here. Notice this is also the slope of the ray. So what that tells me is that to go from one point to the next, I would go up 2 and forward 1, right? Because this is our rise over our run. So if you look at this ray that I've drawn, going from 0, 0 up to our point, notice we went up 2, forwards 1. And I could keep going, right? I could go up 2, forwards 1. I could go up 2, forwards 1. I could go up 2, forwards 1. I could just keep going and going and going, right? And create more and more points on that ray. So what this is saying is, note that this terminal side of the ray also goes to the point 2, 4. So I'm just going to mark that on my graph. So here's 2, and up here is 4. So what I want to do now is I want to use this triangle that goes through the point 2, 4. And I want to see, if I were to use that triangle, how would my trig function values differ, or would they differ? Okay, so I'm going to come over here, just because I have more room up here than I do down here. If I use the point 2, 4, now I know that my x is 2, and my y is 4, right? So I need to figure out what this r length is. So just like I did before with my pink marker, right, I'm going to do this again with my blue marker. So I can find r by doing the square root of my x value squared plus my y value squared. And then I'm going to simplify. So this gives me the square root of 4 plus 16, right? R, which gives me the square root of 20, right? Now, because this is not a perfect square, but it is a radical, we can simplify, right? Because 20 is 4 times 5, and 4 is a perfect square. So I can actually calculate that perfect square. So this gives me r is equal to, the square root of 4 is 2, and then we're left with that 5 still under the radical, okay? All right, so now that I have my x, my y, and my r for this bigger triangle, what I want to do is I want to calculate my sine, cosine, and tangent values and see how they compare to when I did it the first time, okay? So for my sine, when I do y over r, my y value is now 4 over my r, which is 2 square root of 5. And notice, before I even get rid of that radical, I can actually go ahead and reduce this, right? If I reduce on top and bottom by 2, I end up with 2 over the square root of 5. And notice that's exactly what I had before. So I can go through the process again of rationalizing the denominator, and that will give me the same answer, the 2 square root of 5 over Okay, and I'm not writing out that step because I already did it up here, right? Let's see if the same thing is true for cosine. When I calculate x over r, x is 2 over my r, which is 2 square root of 5. Again, I can reduce before I do anything. When I reduce, I get 1 over the square root of 5 because I can reduce those 2's away, right? And then notice that is the same value that I got before, right? And I'm not actually going to go through simplifying it. I just want to show we're getting the same thing, right? And then our tangent value, same thing. If I do y over x, my y value is 4, my x value up here is 2, and 4 over 2 does in fact still give me 2, right? So notice it doesn't matter which point I pick on this line. It doesn't matter if I use the smallest possible triangle or if I use a medium triangle, or heck, I could pick this point, right? And I could do another triangle, you know, using all of this, okay? So it doesn't matter which point on the terminal side I pick, you'll always get the same trig function values. Now, notice what worked out nicer, right, for us is that when we use the smaller triangle, we didn't have as much simplifying to do. The further we go out on the line, the more we're going to end up having to reduce and simplify to get down to that trig function value. Okay. All right, so let's see what this says. I think I answered the question before I read it. It says, how does using different points on the terminal side of an angle affect the value of the trigonometric function values? Okay, so what happens? Well, it doesn't affect them, right? Doesn't affect them. Okay, we can use any one. And why it doesn't affect them, it goes back to similar triangles. You'll remember talking about similar triangles. So if we use the same triangle, right, then we end up with the same ratios when we talk about the lengths of their sides. Okay. All right, the other thing I want to point out is we talked about the tangent value being the slope. There may be some questions on this section where it actually has you find the slope of this the slope of this ray, or it might even have you find the whole equation. Okay, so I just want to make a note down here on how to do that. So if you're looking back through your notes, we remember that we actually covered that. Okay, so down here at the bottom, I'm just going to put a note. Let's see, the ray we initially drew for our terminal side has a specific equation tied to it, right? And so when I say a specific equation, what I'm talking about is a y equals mx plus b, right? And so in order to find that specific equation, really all we need to know is our slope, right, which is our m value, and then we also need to know our y-intercept, which is our b value, right? So remember, our slope we get from our tangent value, and our b value is our y-intercept. So I'm just going to go ahead and move my page back up here. Notice, if I'm looking at this xy axis, any angle that's written in standard form crosses through 0, 0, right? So I'm just going to put a note here. This is my y-intercept, right? Or in other words, b would equal 0 on any equation whose angle is written in standard position. Okay, so I know my b value is 0, and then I can, always count my rise over run, or I can just look at my tangent value. My tangent value was 2 over 1, so my slope is 2. So if I wanted to write an equation for this specific ray that we drew, it would be y is equal to 2x plus 0, right? because 2 is my slope and 0 is my y-intercept. And then obviously if we're going to enter this in my math lab, we don't have to write the plus 0. So for this one, we would just enter y equals 2x for the equation of this line. Okay? All right. So now, this one we actually drew the picture and then we figured out what the equation was. On some of them, they will give us the equation and then we have to come up with the angle, and draw our triangle off of it and all that kind of stuff. So let's look at one like that. Let's look at page 3. All right. Page 3. It says graph 3x minus 2y equals 0. Now, when I go to graph this, I always like to put it in slope-intercept form, right? We always want it to look like y equals mx plus b, because that's a lot easier to graph, because all we have to do is plot the y-intercept and then count the slope, right? So I'm going to take this equation that they gave me, the 3x minus 2y equals 0, and I'm just going to solve it for y. So I'm going to move my 3x to the other side. So I have negative 2y is equal to negative 3x. And then I got to get rid of this negative 2. So I divide that off. And I end up with y is equal to 3/2 x. Right? Or if I want it written like y equals mx plus b, if I don't have another term out here, it's like a plus 0. Right? So this is my slope. And this is my y-intercept. Okay. So my y-intercept, it crosses at 0, 0. So I'm going to go ahead and put my point there. And then I want to count my slope. So this means that I am rising 3 and running 2. So up 3, 1, 2, 3, forwards 2. Up 3, 1, 2, 3, forwards 2. And then I don't just always want to draw it in this quadrant because I may not be looking at that side of the ray. So I want to make sure I draw it in the other direction too. So instead of going up 3, forwards 2, if I want to go in the opposite direction, then I would have to go down 3, backwards 2. Down 3, backwards 2. Okay, so here's my line. So that's the first thing I did, is just to graph this line. Okay, all right. So now let's look at what we're going to do with this line. Let me scoot it up here. I don't know where that shadow's going. I guess it's coming from my shoulder or something, because every time I lean over, there's a dark spot. Sorry. Okay, so now it says, now graph the portion of this line where x is less than or equal to 0. So when we're looking at x is less than or equal to 0, that means my x's have to be negatives, right? For them to be smaller than 0, they need to be negatives. So I'm just going to say, looking at negative x's. So if I look at this line that I just drew, and I want to only focus on where I have negative x values, then that's going to be, well, here's where x is 0, right? And then my negative x values are in this direction. So that means I'm only looking from this point at 0 down this side of the line. Okay? Because this is where I have negative x's. So I don't care about this side of the ray. I went ahead and graphed it because it's on the line. But basically what this tells me is that I am looking for this function that has this angle. Right? My terminal side is the side over here where I have negative x values. Okay, so I want to go ahead, and part C says to find the 6 trig function values for an angle theta whose terminal side coincides with this line where x is less than 0. So basically it's just saying we're talking about this angle theta here. Okay, recall what you need to know. Okay, I need to know an xy point so that I can use that xy point to find r, right? I need to be able to draw my little triangle, right? So I need a point on this line. Well, when we started counting, when we were trying to figure out how to draw this line, right, we counted our slope. So we went up 3, forwards 2, up 3, forwards 2, up 3, forwards 2, right? Or going the other way, we went down 3, backwards 2. So I'm going to go ahead and just use this point right here. So if I look at that point that I plotted, I got that from going down 3, backwards 2. So the ordered pair that I'm going to use there, if I go down 3, backwards 2 is a negative 2x value, right? And down 3 is a negative 3 for my y value. Okay. So that's pretty good. I'm over halfway there, right? I know that my x is negative 2. I know that my y is negative 3. And now I just have to figure out my r, right? So in order to find my r, remember r can be found by taking the square root of our x value squared and our y value squared. Now, we want to make sure we put the parentheses around the negative because we're squaring the whole number, right? So this is going to give us r is equal to the square root of 4 plus 9, which gives me an r value of the square root of 13, which just happens to be ugly, right? There's nothing I can do to simplify that. It's not a perfect square. I can't pull a perfect square out of it to simplify. But now that I have all of my values, now I can go ahead and figure out what my trig function values are. So remember, sine theta, sine we get by doing our y over our r. So our y in this case is negative 3 over our r, which is the square root of 13. And then my math lab always has us rationalize our denominator, right? So we're going to go ahead and just multiply on top and bottom by the square root of 13 over the square root of 13. Okay. So we end up with negative 3 square root of 13 over square root of 13 times square root of 13 gives me square root of 169, which is then just 13. Okay. Now you'll do this several times to where you may not even have to write in this step. You'll probably be able to go from here to here. I'm fine with that. Okay. But if you are still a little shaky on rationalizing the denominator, go ahead and write that step in just so that you don't make a silly mistake. Okay. So there's our sine value. Now we want to look for cosine. Remember, cosine, we find its value by doing the ratio of x over r. So my x value here is negative 2 over my r value, which is the square root of 13. Again, we have to rationalize the denominator, so we're going to multiply by the square root of 13 over the square root of 13. And that gives us negative 2 square root of 13 over 13 when we simplify, right? Okay. And then the last one we need to do is our tangent, which most of the time is our easiest one to calculate. So tangent is y over x. So if I look at my y value over my x value, that gives me, what did I just say, y? Negative 3 over negative 2, right? And then a negative over a negative becomes positive. So we do want to simplify when we have more than one sign. Okay? Maybe not the worst thing. All right, so I really only have one more thing to go over. The examples that we've done so far have dealt with angles with a ray that creates a triangle. But we actually have some specific angles that do not create triangles. And those angles are called quadrantal angles. So I don't know if you remember quadrants of a graph, right? Back in college algebra, we talked about the quadrants. This was quadrant 1. This is quadrant 2. This is quadrant 3. This is quadrant 4, right? And we talk about where it falls. If it falls in this quadrant, it has this kind of x value or this kind of y value, right? Now, when we talk about quadrantal angles, basically what we're talking about is not angles that fall within these quadrants. They're angles that fall on the actual axes. Okay? So quadrantal angles are angles that lie on an axis. Okay? So let's think about angles that would fall on an x or a y axis. So the first one that I can think of is the one we're probably all most familiar with, right? Which is this one. If I have 90 degrees, right? A 90-degree angle falls right here, right, on the y-axis. Okay, we might also have like 180 degrees, right? That would fall over here on the x-axis, right? It would be the same if I had, say, like a negative of either of these, right? I could also have like this angle. This would be a negative 90-degree angle. That would fall down on the y-axis, okay? So when we talk about quadrantal angles, we're basically talking about like 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees, right? And we could keep going because we can make more than one revolution, right? 360 is all the way around, right? That would fall right here if I did 360 degrees. But I could go 360 in the positive, I could go 360 in the negative, I could go 720, right? I could start making more revolutions. So really it's any of these angles or more copies of those, or the negatives of these angles, meaning the same angles but just going in the negative direction when we go clockwise rather. Okay, all right, so what makes these different? Well, they fall on an axis, and so when it falls on an axis, you know, if I said, okay, let's look at 90 degrees, how would you draw a triangle using that point, right? So let's go ahead and look at a couple of these just so we can see, well, what do we do if we encounter this, right? So this first example says, let's find the trig function values for 90 degrees. So 90 degrees would be right here, right? This would be our terminal side for 90 degrees. 90 degrees. Okay, so this is our 90 degrees. So what we need to do is we need to pick a spot, a point on this. Now remember how we talked about back when we had you know, one that made a triangle, right? We talked about how we could choose this point, we could choose this point, we could choose this point, right? Because these are all going to create similar triangles. So I can pick any point on that terminal side, that ray. So the same thing is true if my terminal side happens to lie on an axis, right? I could pick any point. I could pick this point, I could pick a point further up or further up or further up or further up, right? So if I think about points that lie on my y-axis, that would be points like 0, 1, 0, 2, 0, 3, 0, 4, right? Just slowly going up the y-axis. So I'm going to go ahead and just put a note here. Recall, we can pick any point on the terminal line because they all lie on the same ray with the same angle measure. Okay, I'm not going to write all that out. I'm just going to say we can pick any point on the terminal line. And that's wonderful. Wonderful. Pow. I feel like we should say that like the old Batman movies. Pow. Okay, we can pick any point. So I'm going to pick a point that's nice and pretty, like 0, 1. I mean, why would we not pick that? We could pick 0, 11, 0, 13, 0, 589, right? But let's pick a nice pretty one. So then that means I know my x value, right? Because my point tells me that my x value is 0. My y value is 1. And then again, I can solve for r. So remember, r we get by taking the square root of our x value squared plus our y value squared. So if I simplify this, this just tells me that r is equal to the square root of 0 plus 1, or the square root of 1, which again is just 1, right? So even though it looks a little bit more confusing when we first draw it, it actually ends up being a lot easier because look at how pretty our values are, right? So now if we want to find sine of theta, remember that's our y over r. our y is 1, our r is 1, and 1 over 1 is 1, right? Our cosine is x over r. Our x value is 0, our r value is 1, and 0 divided by any number, right, is 0. I guess I shouldn't say any number. 0 divided by 0 is undefined, but we won't see that in this class. All right, tangent theta is y over x. So y is 1 and x is 0. So notice this is something we haven't seen before. Remember, when 0 is under the fraction, then it's undefined. Okay, undefined. So for a quadrantal angle, we're going to end up with undefined values. That's the kicker. That's the difference here. Okay, and then I'm going to go ahead and find the reciprocal ones. Actually, I'm going to let you find the reciprocal ones. So if we want to find sine theta, you need to do the reciprocal and simplify. So I'm going to go ahead and let you pause the video to fill these in, and then when you're ready to check yourself, unpause it. We'll see how you did. Okay. All right, let's see how you did. So cosecant theta is r over y, so that's 1 over 1, which simplifies to 1. Secant theta is the reciprocal of cosine, so r over x, which gives us 1 over 0 when we flip those, right? So this one's actually going to give us an undefined value. And then cotangent theta is the reciprocal of tangent. So if we do x over y, we end up with 0 over 1, which then is no longer undefined, right? It's just 0. Okay. All right, so when we're dealing with quadrantal angles, remember, we go ahead and draw it, figure out where its terminal side is, and then we pick the easiest point that falls on that terminal side. Once we have our point, that gives us our x and our y, we can solve for r, and then once we know x, y, and r, we can fill in all of our trig function values, okay? All right, so on the next page, I want y'all to try it all by yourself, okay? Let's see how it goes. So now we're looking at 180 degrees. So I want you to draw 180. Make sure you write the terminal line where it ends, right, the ray. Find a point on that ray, label your x and y, figure out your r, and then fill in all your values. Okay, so this is kind of a big one. We're going to do it all by yourself, but I have faith in you guys that you can do it. So go ahead and pause the video, and if you get stuck or if you get finished and you're ready to check yourself, unpause it and we'll see how you did. Okay? Okay, let's go ahead and see how you did. I didn't work it all the way out, but I want to make sure we got at least to this point. So when you draw 180 degrees, its terminal side is over here on the negative x-axis, right? Now we can pick any point on that line. So I would just go out 1 unit, right? Just pick a point that's just 1 unit out. Now if it's 1 unit out in the negative direction, that means at that point would be -1, 0, okay? Now again, you could pick any point out there. You could pick -2, 0, -5, 0, -5,000, 0, right? But I'm just picking the smallest one just to make life easy. So that means that my x is -1, my y is 0, and then I can figure out my r by just calculating it, right? You can also figure out your r because you know r is just the positive distance from 0 out to your point, right? So if you look here and you know you just went 1 unit out, you should know that your r is 1, right? But remember, r is always positive. So if there's any doubt in your mind, go ahead and work it out and just make sure we get the right thing, okay? All right, and now that we know what x, y, and r, what those values are, we can go ahead and figure out our trig function values, right? I'm gonna focus this again. Keeps looking out of focus to me. All right, so our sine theta is y over r, okay? Y over r in this case is 0 over 1, which is just 0, all right? Cosine theta is x over r. X is -1 over 1, So that's -1, right? Tangent theta is y over x. Remember, that's where we get our slope. Our y value is 0, and our x value is -1. So we have a 0, which makes total sense, right? Because remember, if this one represents the slope of our terminal line, right? Notice here our terminal line is a horizontal line, right? Horizontal lines have 0 slopes. Okay, all right. Cosecant theta is the reciprocal of sine. So that's going to be r over y. So 1 over 0, which ends up being undefined, right? The 0 is underneath, it's undefined. Secant theta is the reciprocal of cosine. So r over x, which is 1 over -1, which still gives me -1, right? Cotangent is the reciprocal of tangent. So that's x over y. So -1 over 0, which again gives me an undefined value. Because 0 underneath means undefined, okay? All right, so the last thing I want to point out is that we can actually kind of determine the signs. So like notice here, these both came out to negatives. We can determine the sign of our trig function values based on the quadrant that it falls in, okay? So we're just going to kind of refresh here, okay? Notice I have the x coordinate and I have the y coordinate. The reason I didn't list the r is because r is always positive, right? R is always positive. So we're talking about the signs. A positive never changes the sign of a number, right? Only negatives will change things from positive to negative. Positives don't. So let's go ahead and look at if something's in quadrant 1. So again, remember, recall, this is quadrant 1, this is quadrant 2, quadrant 3, and quadrant 4. So if it lies in quadrant 1, I want to know what kind of x value does it have and what kind of y value does it have, right? Well, in quadrant 1, over here, this is our x's, right, and this is our y's. If it's in quadrant 1, it has a positive x, right? So x's are positive. And I'm just going to write it down here. So over here, we have x's are positive. And our y's, if it falls over here, our y's are also positive, right? Because down here is where negative y's are. So these are also positive. So x's are positive and y's are positive. Maybe I should write it like this. Positive, so it's not a t. Okay, let's look at quadrant 2. Now when we move over here to quadrant 2, now our x's are no longer over here on the positive side, right? They're on this side of 0. So in quadrant 2, our x's are negative, but our y's are still above 0, right? So our y's are still positive. So I'm going to go ahead and just write over here. On this side, our x's are negative, and our y's are positive. Okay. Again, we don't care about r because r is always positive. If it were in quadrant 3 down here, notice x's are negative on this side, right? And y's are negative on the bottom. So if we're in quadrant 3, both x and y are negative, right? Because x's are on this side of 0 and y's are below 0. So they're both negative. So again, I'm going to go ahead and just write it here. X's are negative and y's are negative. Oh, you can't see what I'm writing, can you? Ha ha ha. So I can get it all on there. I don't know if I can scoot it up enough, maybe. Hopefully that's not cutting it off. Okay, and then our last one is quadrant 4. So if we're over here in quadrant 4 is back where the x's are positive, but our y's are still below 0, right? So they're still negative. So here our x's are positive and our y's are negative. Okay, so I'm going to just scoot this down, or scoot it up rather, and just look at this. So these are my quadrants, right? notice on the top two, my y's are positive. On the bottom two, my y's are negative, right? And then on the right side, my x's are positive, right? And on the left side, notice my x's are negative. Now, why is this important? Because we can easily determine the sign of the trig function just by thinking about the x's and the y's, right? Because the sign values are going to be determined by the y, because sine is y over r, right? And since r is always positive, it's not going to affect the sign of the sine, right? So I'm going to just put a note over here. The sine, meaning positive or negative, okay, of sine theta depends on the sine of the y value, okay, because r is always positive, okay? So all I can do is I can go around now and determine if all of these signs are going to be positive or negative, right? Because here my sine value, my y's are positive, so my sine value should be positive. In quadrant 2, my y's are positive, so my sine value should be positive. Okay, quadrant 3, my y's are negative, so my sine value should be negative. In quadrant 4, my y's are negative, so my sine should be negative, right? Because the way that we calculate sine is doing y over r, right? And since r is always positive, sine, the y value is what gives us basically whether it ends up being positive or negative, okay? And then similarly with cosine, okay, the sine, meaning plus or minus, of cosine theta depends on what? I heard you say it. I didn't, but I'm pretending I heard you say it. Okay, the sine of cosine, remember cosine is x over r, right? So it depends on the sine of the x value, right? Because r is always positive, right? When we draw those triangles, r is our hypotenuse, right? Which always represents a distance, so it's always positive. So if I want to know the sign of the cosine function, then all I have to do is look at the x's. So if I look at cosine in the first quadrant, my x's are positive, so cosine is positive, right? If I want to look at the cosine function in quadrant 2, I just look at the x's. Since they're negative, my cosine should be negative, right? When I look at the cosine in quadrant 3, my x's are negative, so it should be negative, right? And then cosine in quadrant 4, my x's are positive, so it should be positive. I'm sorry, hopefully this is not running and making that more difficult to see. All right, and then when we look at our tangent has to do with x and y, right? So the sine of tangent theta depends on both x and y values, right? Because tangent theta, remember, is equal to y over x. Now, it doesn't matter, if we're talking about tangent or cotangent, right? The reciprocal, but we do need to know the signs of both, okay? So let's look in quadrant 1. If I look at my tangent, if I have positive x's and positive y's, so positive over positive is still positive, right? If I look in quadrant 2, my y's over my x's give me a positive over a negative, and a positive over a negative turns out negative, right? And then tangent in quadrant 3 down here, I get y's over x's being negative over negative, and a negative divided by a negative is positive. And then in quadrant 4, our last one, our y's are negative and our x's are positive. So negative over positive ends up being negative. Okay, so there will be a few problems on your homework where it just asks, you know, if you're trying to find the tangent value of an angle that falls in quadrant 3, you know, should it be positive or negative? So you don't actually have to know what your theta angle is. You don't have to know an XY point. If they're just asking for the sign, all you have to do is think about what your X and Y signs are in quadrant 3, and you should be able to figure out the sign of the trig functions, right? And if you get stuck, you can always refer back to this page. Okay, so don't forget to, on this assignment, to rationalize your denominators. I always have people who tell me they miss a ton of problems even though they're doing them right. So don't forget to rationalize your denominator. And if you have any questions, please let me know.